In this video, we're going to try and work out the area underneath this graph from 1 to infinity. We've already seen this, 1 over x squared from 1 to infinity. When you try and work out the area of this, for some reason, this thing here will converge to one particular value here. It will converge. But if you try and do the same for this, from 1 to infinity, for some strange reason, this thing here will diverge. This thing here will diverge, whereas up here, it will converge. So let's try and understand why it diverges. So we're going to integrate this from 1 to infinity. So our usual strategy would be to integrate it from 1 to an arbitrary point b, and then later we can allow b to head towards infinity. Okay, so let's try and integrate this. So let's try and integrate it from 1 to b first. So let's try and integrate it from 1 to b. So integrate this, it will then give you the natural log of the absolute value of x. But because 1 is always positive and b is always positive, you don't really need this absolute value here. You can just write this. You can just write this from 1 to b. Okay. Well, integrate this. It will then give you this. So now it's a matter of you putting this into here. That will then give you this. Put this into here. That will then give you this. This thing here, natural log of 1. Remember, your natural log graph looks like this. This here is 1. So natural log of 1 is actually 0. So this thing here will be 0. So when you integrate it from 1 to b, it will then give you this thing here. So now we would allow b to head towards infinity. So now let b tend towards infinity. Then this thing here will then become this. So the minute you allow b to head towards infinity, you're actually integrating it from 1 to infinity. But then on the right hand side, this becomes this, because you're taking the limit of this thing as b tends to infinity. So this thing here will then become this, and then this thing here will then become this. The minute you allow b to head towards infinity, then this will become this, and then this will become this. Now, if you look at this, natural log graph will look like this. As b heads towards infinity, you can see it's always growing and growing and growing and growing. So this thing here, this whole thing here, will head towards infinity. So there is no area for 1 over x. What this is saying is that the area will get bigger and bigger and bigger and bigger. So you can't work out the area of this. It doesn't converge. It diverges. So there is no area for 1 over x from 1 when you try and integrate it from 1 to infinity. So what's happening is this. For some reason, this thing here, if you try and integrate it from 1 to infinity, this area here will converge. But then when you try and do the same for 1 over x, the area will just get bigger and bigger and bigger. The area doesn't converge, so we can't really work out the area. It would just tend towards infinity. The area will keep on growing and growing and growing. But whereas this one here, for some reason, it converges to one particular value. The reason why the area there diverges is because of this. When you integrate it from 1 to b, it gives you this. But then when you start to take the limit as b tends to infinity, if you look at this bit here, it is always growing. This thing here, as b tends towards infinity, natural log keeps on growing and growing and growing. So the area is always growing and growing and growing. So this here, the area of 1 over x from 1 to infinity, it will head towards infinity. It is infinity. Okay.